Good morning, children. Chapter 6 Chemical Reactions. So, today we are going to discuss different types of chemical reactions. In that, we are going to learn combination reaction, decomposition reaction, and displacement reaction. So, let me discuss one by one. First one, different types of chemical reactions. There are four basic types of chemical reactions. There are combination reaction, decomposition reaction, displacement reaction, and double displacement reaction. Let me discuss one by one. First one, combination reaction. What is a combination reaction? When two or more elements or compounds combine to form new product is called a combination reaction. So during a combination reaction, either two elements or two compounds or one element, one compound, they will combine and produce new substance. So it is a combination reaction. A new substance are produced, new compounds are synthesized. That's why combination reaction is also called as synthesis reaction. Look at the example. Hydrogen combines with chlorine, produces hydrogen chloride. So hydrogen chloride, a new compound is synthesized. Therefore, combination reaction is also called as synthesis reaction. Let me discuss more example to understand the reaction. Formation of carbon dioxide and sulfur dioxide. Carbon, a non-metal, combines with oxygen, produces carbon dioxide. Likewise, sulfur also combines with oxygen, produces sulfur dioxide. So these two are burning process. You know that burning process means always it liberates some heat energy, light energy, and it burns with a flame. So sulfur burns in oxygen with a blue color flame, and it produces sulfur dioxide. So carbon combines with oxygen, produces carbon dioxide. Sulfur combines with oxygen, produces sulfur dioxide. So it's an example of a combination reaction. Formation of magnesium oxide and calcium oxide. So magnesium is a metal. It combines with oxygen, produces metal oxide. Magnesium oxide is formed. And calcium is heated with oxygen and it burns with a brick red flame and produces calcium oxide. So the brick red color flame indicates the presence of calcium in a compound. So combination reaction. These are the examples of a combination reaction. So what is a combination reaction? Two or more elements or compounds combine and produces new compounds. So that is a combination reaction. Now let us discuss decomposition reaction. What is decomposition? So in chemical terms, chemistry, decomposition means a splitting up of compound. So a compound splits up into two or more simpler substances. So that is known as a decomposition reaction. Look at the example A, B, a compound. They split up into A and B. So two new products are formed. So therefore it is a decomposition reaction. Let us discuss a few more examples. And the decomposition reactions are always carried out with the help of heat energy, light energy or electricity, because we need energy to break or to split up a compound. So the energy is provided in any form. It may be of light, heat or electricity. And a decomposition reaction is just opposite of a combination reaction, because combination reaction means two or more elements combined and produces a compound. Here in decomposition reaction, a single compound breaks up into two or more simpler substances. So both are opposite to each other. Combination reaction and decomposition reactions are opposite to each other. For example, calcium carbonate. So it decomposes and produces calcium oxide and carbon dioxide. A single compound decomposes into two new compounds. They split up into two compounds. One is calcium oxide, another one is carbon dioxide. Okay, children? And there are different kinds of decomposition reaction based on what type of energy is applied. Suppose heat energy is supplied means it is a thermal decomposition reaction. Therm means heat. And if electricity is applied means it is an electrolytic decomposition reaction. Photochemical decomposition reaction, that means we are supplying light energy. Okay, so let us discuss one by one. Thermal decomposition reaction. So heat energy is supplied during this reaction. Potassium chlorate was taken and it was heated, and it splits up into two compounds. One is potassium chloride, another one is oxygen. And the reaction was initiated by a catalyst called manganese dioxide. So manganese dioxide acts as a catalyst. What is a catalyst? A catalyst is also a chemical substance which initiates a reaction, or it controls the rate of the reaction. What is rate of a reaction? Means speed of the reaction. So some reactions will occur vigorously. Some reactions will need a starter to start the reaction. So catalyst act initiates the reaction, or it fastens up the reaction, or it slows down the reaction, but it do not involve in the reaction. So catalyst do not involve in the reaction, but they initiates the reaction. So here manganese dioxide acts as a catalyst, and it helps the potassium chlorate decomposes into potassium chloride and oxygen. Okay, so let us see the next example. Lead nitrate, which is white in color, was taken and it was heated. It decomposes, produces three simpler substances. One is lead oxide, yellow color precipitate, and nitrogen dioxide, a brown fume appears, and oxygen also liberated. So nitrogen dioxide and oxygen are gases, and a yellow residue of lead oxide is formed. So this is also an example of a thermal decomposition reaction. Lead nitrate decomposes into lead oxide, nitrogen dioxide and oxygen. Electrolytic decomposition reaction. So electricity is applied during this reaction. So when electricity is passed through acidified water, it decomposes to give hydrogen and oxygen. What is acidified water? It means two or few drops of acid is added in that water. So that is an acidified water. So when electricity is passed through this acidified water, it decomposes, it splits up into hydrogen and oxygen gas. So hydrogen and oxygen gas are liberated when electricity is passed through water. Okay, so it is an example of an electrolytic decomposition reaction. The next one is photochemical decomposition reaction. So here light is the energy. Light energy is supplied to split up the compound. Silver chloride is taken and it is exposed to light. It decomposes and produces silver metal, and chlorine gas is liberated. So these are the few examples of decomposition reaction. The next one is displacement reaction. What is displace? So moving one place to another place. Yes, so displacement reaction. So here one element will displace another element in its solution. So that is a displacement reaction. So it is a reaction in which one element takes the place of another element in a compound or in a solution. Okay. For example, copper sulfate solution is taken. That is copper sulfate, a blue color solution. It is dissolved in copper sulfate is dissolved in water. A blue color solution we get, and in that we have added iron. After few hours, we get a green color solution, which is iron sulfate. So iron displaces copper in its copper sulfate solution. In its solution, iron displaces copper because iron is more reactive than copper. Metals or non-metals, anything. So they have different reactivity. Some metals react with acids or water very vigorously. Some metals react with other elements. Some metals react with in a fast manner. Some metals react very slowly. So based on the reactivity, the displacement reaction will take place. The reverse reaction will not happen because copper is less reactive when compared with iron. So copper cannot displace iron. But iron can displace copper in its solution because iron is more reactive than copper. Okay, so copper sulfate plus iron gives iron sulfate plus copper. and here we have taken iron sulfate, in that magnesium is added. So after a few hours magnesium sulfate is formed. Iron left out from the solution because magnesium is more reactive than iron. So a reactive metal or reactive element will displace, more reactive element will displace a less reactive element. Thank you children.